child or man-child, man, my name is man-to-planet child, so both man and planet my name. Today's topic is this my quantum gravity series video 35, and today's topic is conclusive proofs of the unification of the strong nuclear force, the electromagnetic force, and the force of gravity. This conclusive proofs of the unification of the three forces. In my video 34, that's the last video, in the example shown there, the Coulomb's law, equation of the force, which is obtained by dividing equation 7, which is an equation of potential by R. R means the quantum radius. Quantum radius means the quantum wavelength divided by 2π. And as shown in my video 22. I will refresh your memory by showing you video 20 here. This is my video 22, and the reason the equation 7, which is video 21, if divided by a quantum radius, it becomes an equation of force. Equation 7. If we divide both sides by the quantum radius, it becomes an equation of force. Today is a bit windy. And the example, last video, this is the Coulomb's law. E square, E is the elementary charge 1.602 times 10 to the power minus 19 Coulomb. The square of it becomes 1/4 pi epsilon naught. Epsilon naught means 8.54 times 10 to the power minus 12 farad per meter. And the R here is the quantum radius. And this is the Coulomb's law, exactly. Coulomb's law, quantum radius square divided by. It's equal to this. The equation divided by B. This which is called I now call it a common quantum form equation. The common quantum form exactly this one at the top there. Planck mass divided by Planck length times c square. C square means light speed square. Multiplied by the integral multiple of Planck mass divided by the integral multiple of Planck length. This I now find this one is applicable to all the three forces: the strong nuclear force, electromagnetic force, and the force of gravity. So here enough, I will show you how. The last time actually I have used that equation, the form here. Planck mass times Planck length divided by Planck length times c square times integral multiple of Planck mass divided by integral multiple of Planck length, and is equal to this one, and then is equal to this one, 7.158 times 10 to the power 5 newtons. This is the result. So here again, once again, Planck mass divided by Planck length times c square times integral multiple of Planck mass divided by integral multiple of Planck length. This is I call it the common form quantum equation, because it's all composed of Planck's constant. So it's Planck quantum, or Planck mass, Planck length, c square, and integral multiple of Planck mass, integral multiple of Planck length. I find this, I revise it, and now I find it's applicable to all three equations. All the three equations for the strong nuclear force, the equation for the electromagnetic force, and also for the force of gravity. So once again, so it's equal to 7.158 times 10 to the power 5 newtons. Is the result. And I will also show you what is the result of using the Coulomb's law, which I have just shown you, which is the E square. This is E square. E square, E is 1.602 times 10 to the power minus 19. E square is 2.566 times 10 to the power minus 38 Coulomb square. And then divide by 4 pi 8.854 times 10 to the power minus 12. This is epsilon naught. So the unit is Farad per meter. And then divided by the quantum radius. Quantum radius of the proton, of course, is 0.2103 times 10 to the power minus 15 meter, and square of that. And then also the Coulomb's law, you have to be divided by a alpha, the fine structural constant, equal to 1/137.036. And using this Coulomb's law, it is also equal to 7.5158 times 10 to the power 7 Newton, which proves that the electromagnetic force, when they compute at the same relevant mass, which is 1.6726, the proton mass, and at the same relevant radius, which is of course the proton quantum radius, 0.2103 times 10 to the power minus 15 meter. Then it's completely, when it's computed at this same relevant mass and same relevant quantum radius, then it's completely equal to my common form quantum equation. The result is the same. Both yield the same result, 7.158 times 10 to the power minus 10 to the power 5 newtons. So, what the next question? The next question would be, do these computed values of 7.158 times 10 to the power 5 newtons match the experimental value of this strong nuclear force of the proton? If this value does not match the experimental value, then it's useless. So I have to show that it is equal to the experimental value. And I quote the Cambridge Handbook of Physics formula by Graham Wong of 2000 edition. And there you have a liquid drop model equation, liquid drop model equation, liquid drop model. And in this book, I forgot to write down the page number, but you can just search the index of the book and also the content of the book. Both show this liquid drop model and the equation, the nuclear binding energy equation. And this is the binding equation. B is equal to A minus ASA to the power 2 to the power 2 over 3 minus AC Z squared divided by A 1 over 3 to the power 1 over 3 minus A times N minus Z squared divided by A as the pairing term AP as the here is written delta A. And what is the meaning of all this? I have shown you there's a meaning. All these I quote from the book, exactly quoting from the book. And after you have I've shown you this, I've to say to you what the NAZ means. N means the number of neutrons. A means the mass number, which means the number of neutrons, and plus the number of protons, Z. Z is the number of protons. B is the semi-empirical binding energy. Empirical means experimental. And AB means AB. I just read to you AB. AB means volume term. Is about around 15.8 mega electron volts. AS is the surface term, about 18 mega electron volts. AC means the Coulomb term is about 0.72 mega electron volt. AA is a symmetry term, about 23.5 mega electron volt. AP is the pairing term, the last term is about 33.5 electron volt. Now I show you again once again. These are essentially quotes from the book, Cambridge Handbook of Physics Formula by Graham Worm in 2006. Now, so now you understand what is the meaning of B minus this equation. And then what I actually have to do the calculation for the single proton. All this means all this a to the power 2/3 z square a to the power 1/3 z minus n minus z bracket square divided by a. All these factors all becomes 1 because you have a. You will know from this notations and the interpretation of these notations, then it's a single proton and all is matter in 1. So it means the calculation is 15.8 times 1 minus 18 times 1 minus 0.72 times 1 minus 23 times 15 times 1 plus 33.5 times 1. So the total you can do the calculation yourself. It's simple. And the result is 7.08 mega electron volt. And if you have to convert the electron volt to joules, then you multiply by 1.602 times 10 to the power minus 1.1, approximately 1.1 times 10 to the power minus 12 joules. Yes. And then you have to divide it by alpha because this is a strong nuclear force. Is the E square is equal to elementary charge square. So whenever it's elementary charge square, you have to convert to joules, to the joules, the SI units. Then you have to divide by the alpha, find structural constant. Divided by structure pi 1/137.036. That means multiply by 137.06. Because it's the denominator, if it is 1/137, then in the numerator actually it means 1 multiplied by 137.036. So let's multiply it. Times 10 to the power minus 10 joules. This is the empirical potential. Empirical means from the experimental, because this is an experimental formula. Now it becomes 1.507 times 10 to the power minus 10 joules. And you have to remember, this is a potential. Once again, whenever you have a potential, the energy potential, you have to divide it by the Compton radius to get the force. So you divide by 0.2103 times 10 to the power minus 15. and so you get that is 7 again 7.158 times 10 to the power 5 newtons. It's the same. Of course, there must be some little discrepancy in the decimal places, because you have to divide so many numbers, multiply by so many numbers, all of which have decimals places. So when you round up these decimal places for the multiplication, it's definitely there will be some small discrepancy in decimal places. This may be you multiply with 7.146, something like that. But then actually correct is accurate because you have to divide by so many numbers, and each of the numbers has decimal places, so you have to round it up to become definitely have some, that will be some discrepancy in the answer. But that's actually correct. And that is note that the coefficient values here are empirical and approximate. This I also quote directly from the book, from the Cambridge Handbook of Physics Formula. That's since you see both the Coulomb's law equation and common with the one divided by me, the common quantum form equation. This common quantum form equation, they knew the answers which match the experimental value of strong nuclear force exactly. And this conclusively proves that the electromagnetic force and the strong nuclear force are one and the same force. Now, because I've shown it matched the experimental value, so I can say that it is a strong nuclear force value is 7.158 times 10 to the power 5 Newton. And then if you use a Coulomb's law equation to calculate it, and using the proton mass and the proton quantum radius, you get the same 7.158. That means that the Coulomb's law equation and the common quantum form equation are both, which are used for calculating the strong nuclear force, are both correct, and they are both equal. And this conclusively proves that the electromagnetic force and the strong nuclear force are one and the same force. The other example of using my common form quantum equation in video 2034. That's what the other example. Last time, in my last video, in my last video 34, I demonstrated that using my common quantum form equation, the equation derived by me, it can exactly reduces the using my quantum form equation, this one quantum form equation, I exactly reduces it to the Newton law equation. That means there is no difference in the my common form equation and the Newton's law equation. So you see, applicability of the power of the common form quantum equation derived. But there's something to note is that in what does the integral multiple of Planck mass and what is the integral multiple of Planck lengths in the common quantum form equation divided by me? They mean that in principle they will be integers. When you multiply, you divide the mass by the Planck mass, then will be an integer. And also, if you divide the length or distance by the Planck length, they will be an integer. Why? Because in the Planck black hole theory, my Planck black hole theory, and or the new hydrogen atom model, each hydrogen atom is correlated to one Planck black hole. So the mass of which is one Planck mass to an extremely high degree of accuracy. This is due to the Fourier series theorem, which is too lengthy. It will be lengthy for 1 hour to explain. To explain here, it must each Planck black hole must have mass equal to one Planck mass. And so the total number of Planck black holes or hydrogen atoms, one Planck black hole to one hydrogen atom, must be an integer. There's no half hydrogen atom, half Planck black hole. Must be one, always an integer. So that's why I call it the integral multiple of the Planck mass or Planck length, as the case may be. For example, in the above example, if you divide 1.9x9 times 10 to the power 30, this is the mass of the sun, and 5.974 times 10 to the power 24, this is the mass of the earth. And then you divide it by, if you divide by the Planck mass, 2.177 times 10 to the power minus 8, then you get something like 5.4581056 times 10 to the power 70, or 5.458101056 times 10 to the power 61. This is an exact integer. Secondly, you have a look at the Planck mass or the Planck length in the denominator. They should match the number of masses or lengths in the numerator. That is to say, one Planck mass in the denominator for one mass, for one distance, for one Planck length for one distance. So to say, if you have the mass of the sun and the mass of the earth here, then you have to divide it by 2 times, 2.177 times 10 to the power minus 6, and then 2.177 times 10 to the power minus 6, 2 times. If you have the one distance here, as in the last example, in the strong force, you have only one mass here, 1.6726. 1.6726 times 10 to the power minus 27. Then you have only divided by once, 7.77 times 10 to the power minus 6 once. And similarly, for the distance, you have only 0.2103 times 10 to the power minus 15. So you have to divide only by once, 1.616 times 10 to the power minus 35. You have divided by only once, 1 to 1, so say 2 to 2, and 3 to 3 if there's feed. And the common law form equation, the common quantum form equation derived by me, can even reduce a Coulomb's law equation. This is the form, Coulomb's law equation. Q times Q. Q means the charge. Divided by 1 time